My friends, my friends, my friends, my friends, my friends, my friends. My friends, my friends, my friends, my friends, friends, my friends. Welcome. In this video, here are two problems that we went over on the last video to close it off, but what the heck? Let's just go over it one more time as we begin with our inequalities. So let's start with the left. Now it says which one do you think is the correct one for the graph, and pretty much the idea is to try to show you graphically how this looks like. So remember, this y is greater than 4. Let me just go ahead and draw it over here. This y is greater than 4. Okay, doesn't have a little line underneath, which is equal to, so that means the y value always needs to be bigger than 4. So it has to match the graph on the left. Whenever you see the dotted lines like that, that means it does not equal 4. But look at the shaded region. Well, is it bigger than 4? Well, yeah, all the y values are bigger than 4. It's all shaded up here. And by default, this one then has to be this. Y is greater than or equal to 4. And it's that way because it's, look at here, this is a solid line. Anytime it's a solid line, that concludes to us that it can equal 4, but it also, because of the shaded region, it needs to be bigger than 4. Okay, now how did I know this was y is greater than? Well, I think I showed you in the previous video. What I really like to do is I like to put little dots right here. The fact that there's two dots over here means this side is going to be bigger. Y is bigger than 4 because, well, there's only one dot here and there's two here. My friends, my friends, my friends. And now let's go to the right side here. We want to graph y is less than 5. How do I know it's less than? Well, if I go ahead and draw my inequality and make my 3 dots, which side has more dots? The 5. So 5 is bigger than y. Or we like to read from left to right. So y is less than, because it has 1 dot versus 2. Y is less than 5. So does it have the equal to symbol? No. So I'll start off by drawing my dotted line, and I will use a different color. Why not? Let's stick with the gray theme. So I will draw dotted lines like this at 5. Okay, and it says less than. Well, that just means we need to sketch underneath here, and obviously trying to shade all underneath, which is less, like 4, 3, 2, 1 is all less than 5. Okay, I shade under here. Okay, over here, y is less than or equal to 5. Well, now that it has the equal to symbol, that means it's got to be a solid line. So I draw y is equal to 5. Okay, and it has to be less than. That's why we're not drawing anything up here, because this is 6, 7, 8. It needs to be less than 5. So 4, 3, 2, 1, etc. So we can then begin to shade down this region here. Okay, obviously the shading tool is not as nice, so you can just see it's just down over here. Boom. All right, that was just a little reminder. So let's take a look here. Select the graph that shows the solution set to y. Let me change colors. I'd like to do something like yellow here. It looks very beautiful. Y is bigger than negative 2/3 x plus 5. So I want to be able to match these graphs, and let's try to critically think through how we can solve this out. Okay, because we have this plus 5, that's going to tell me my starting value. So if you look at the graph, well, they all start with 5, right? You can see right here, all these lines touch the y-intercept is 5, our starting value. So that's not going to give it away. Well, the slope is negative, and it's negative 2/3. Well, if you look at this graph here, all the graphs have the exact same slope, it looks like. So we're going down 2 over 3. So I go down to 1, 2 over 3, and it hits this line perfectly there. And I could do the same thing over here, down 2 over 3. So the slopes match up. If I was to do that for every graph, the slopes match up the y-intercept. So really what's going to come down to is the shaded regions. Notice how they all have different shaded regions. Well, first things first, looking at this equation, this is y is greater than. I can make my 3 dots. Does it have the equal to symbol? Well, my friends, my friends, my friends, it does not. So since it does not, that means what on the graph? That means our graph should have a dotted line. It should not be solid because it doesn't have the equal to. So right away we know that we can cross off A and we can cross off D. So that leaves us with these two graphs. Now it says it's greater than. So since we're greater than, well, if we're greater than, that means we're going to be up here, right? We're greater than. We got to be larger than that line. We need to be above this line. So it needs to be up over here. So therefore, I can conclude then that the graph has to be B. And now C, because C, well, this is lower, right? And our equation said y is bigger than. So that's how we can think through this and make sense of which one of these matches with that graph. So let's look here. There are two equations below. Determine which one is the one that matches the graph and justify. Well, first things first, what's the starting value? Well, I see the 1 out here, which doesn't have an x next to it. That tells me it's the starting y value or the y-intercept, and they all have that there. Well, look over here at the inequality. It says y is greater than on the left, and to the problem on the right, it says y is greater than. So what does that mean? Well, that means the line needs to have a dotted line. Well, does this graph here have a dotted line? Well, it does. So there it is. So now we have to, what is left to try to look at? Well, the slope, right? This one right here says 1 over 3. This one says 2 over 3. Notice they're positive, so it means we go up 2 over 3. So I'm going to go up to 1, 2 over 3. 1, 2, 3. And I make my line here. Well, does my line connect to these two dots? No, it does not. It does not go 2 over 3. So I'm immediately going to conclude that can't be true. And let's look at this one. Y is greater than. Well, 1/3 x. Well, the 1/3. Well, that means I go up 1 over 3. So up 1 over 3. 1, 2, 3. Ah, look, and it hits exactly on the line. Up 1 over 3. So I can conclude now, okay, this equation matches this graph. And if I was to justify why, well, the starting value is 1. My slope matches, which is 1/3. And since we have y is greater than, it should be shaded. And a shaded line and above, since it's saying it's greater than, right? Greater than should be up above. So there it is. I can use these, and just like you would, this is a great way to justify it to me. Obviously a little bit more nicer, I guess, but that would work, my friends, my friends, my friends. To the next problem. So let's see, given the equation below, can you sketch the function? So let's just understand how to sketch these. Well, first things first, okay? What's my starting value? Well, this right here doesn't have the x next to it, right? So this is my starting value at -3 right there. And, well, this is 2x. Well, my slope is 2, but in reality it's just 2 over 1. There's like an invisible 1 underneath. Notice up above it was 2/3. It gave us the rise over the run. Here it doesn't give us anything underneath, so we assume it's 1, where you see the 2x. So instead of 2x minus 3, it's really like 2 over 1. What does the inequality say? Well, the inequality says we have to be less than or equal to. That means it can be equal to, should be a solid line. So let's begin to sketch this then. So 2 over 1x minus 3. So these are all positive. So that means I'm going to go up 2 over 1. So up 2 over 1. Up 2 over 1. Up 2 over 1. And I can do that to the left. Down 2 over 1 just to make it match the graph. And it has to be equal to. So it has to be a solid line. And now, what does it say? Y is less than. That means it has to be less than, right? So, well, if we're less than, that means we have to be below the line. So that's going to be down over here. So we're going to sketch this region underneath here, below the line. So obviously not the most perfectly, beautifully drawn graph in the world, but there it is, my friends. Okay, that was terribly drawn. I'm just going to try to do something like this here. Boom, 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 boom. Maybe that's better. I don't know. Yeah, I just wish I could draw it nicer. Okay, challenge problem. Sketch this last problem. So y is less than or equal to 2x minus 2. What's my starting value? -2. Well, notice how the axes are going by 2's over here. It was 0, 1, 2, 3, 4. Here it goes 0, 2, -0, 2, 4, 6, and then -2. So just notice that the scaling is different, but it does not matter, my friend. So here it is at -2. Okay, now it's saying y is less than or equal to, so we know it's going to be filled in line. It's going to be a filled in line. It is not going to be dotted, okay? And what's my slope? Well, my slope is 2x. Well, does it have anything on the denominator? No, so we just assume it's like 2 over 1. Our slope doesn't have a negative, so it's going up, not decreasing. So we got to go up 2 over 1. So here's the kind of part that's tricky. Well, in between 0 and 2, there's like 1 here. So 0, 1, 2, 3. And you can fill it in if you want, but I'll just try to estimate it the best that I can. So here's the thing. I need to go up 2. Well, it wouldn't make sense to go like this. Okay, because the axis is already scaled to be 2. So when I go from -2 to 0, that's 2, and I got to go over 1. Notice over 1 has to be right here in between 0 and 2. If I go all the way to 2, that means it would have been 2 over 2, which wouldn't make sense. So what we need to do then is 2 over 1. So go up 2 over 1. There it is. Now I need to go up 2 from, and we only need to go to 0 to 2 because it's already 2, up 2 over 1. There it is right there. So you could see your line is going to look something like such. So down 2 over 1, down 2 over 1, and it's going to look something like that. Notice how I have it filled in because it had the equal to, okay? And it says less than, so now we just know it has to be underneath the line. It's got to be less than, so it's down over in this region here. Okay, so that's a little bit of a challenge problem. We'll get to this last one here just to show you kind of now putting it all together the way I'd like for this to be worded. So the graph shown represents the set of ordered pairs that are solutions to inequality. Pretty much we have this solution with this inequality over here. Okay, we want to enter the inequality. Essentially, we want to enter in an equation. So we want to enter in an equation that best represents the solution set by the line and the shaded region in the plane. Oh, should say plane. Basically, this is our x and y plane, and we want to basically write an equation. So what's my starting value? Well, my starting value, I'm looking at the graph, is -1. So I know if I start my equation, okay, let's look. It's a dotted line. It's a dotted line, so we know it cannot be equal to. And where's the shaded region? Well, up above, so it's got to be greater than. So we know for a fact then, just starting off, it's going to be y is greater than, okay? What's my starting value? -1, okay? And now I'll go ahead and make a dot wherever I find the next perfect point on our grid, which happens to be right here. So -1, and notice we're going up 2, so up 2, so we know it's positive, over 1, so plus up 2 over 1 times x. And then if you do that again, up 2 over 1, and it matches the graph perfectly. So now I can write this as y is greater than -1 plus just 2x. Or, like we've seen on the other problems, we could just write it as 2x minus 1. Again, the -1 is just our starting value, and the 2x is our 2x. Remember, it's a shortcut for addition, and that's essentially what we're doing. We're just adding 2 and over 1, adding 2 over 1, add 2 over 1, and that's why the 2 has the x attached next to it. So enter the inequality. Well, it's either going to be this one or it'll be this one, whatever you prefer, and we can write it in down below here. Okay. Hopefully this is helping, my friends. I'll help you out with this last one here. Notice in this problem, it's kind of a challenge problem. Maybe we can consider this to be somewhat exceeding here. Notice how we like our equations to be y and then everything else on the other side. Well, we have the x and the y here. So all I want to do is solve for y, right? Because it's kind of hard to sketch a graph like this. So all we really got to do is we just subtract x to both sides. And there's no x on the right-hand side, so we just put a minus x here. This is gone. We get y is greater than or equal to 1 minus x. Okay. Now remember, if there is no number in front of the x, we assume it's like a 1. We put an invisible 1. So if we want to sketch this, notice this is y is greater than or equal to, so it's going to be a shaded line filled in, and it's going to be bigger than, so we should expect it to be up above. What's my starting value? Well, my starting value is the 1. It's the number that does not have a variable attached to it. It's 1, which is right there. It's between 0 and 2. I'll call that 1. And what are we doing here? Well, we're going down. This is -1 over 1, right? We're going to go down by 1 and then over 1. So we're going to go down by 1 over 1, which is right here. Again, notice that the scale is slightly different, which is what makes it hard. So down 1 over 1. So notice how the scale is different. Down 1 over 1. It does make this a bit challenging. Up 1 over 1. Up 1 over 1, and it's going to look something like that, filled in, okay? And it says greater than or equal to, so since it's greater than, that means it's got to be above the line, which is going to be up there, okay? So a little bit of a challenge, but you just have to look at the grid and notice that our x and y grid has a scale of going by 2, so anytime we go up 1 over 1, it's going to be in between. All right, take care, my friends. Hopefully this helps you with this video, my friends, my friends, my